So in this video, we continue our work with solving quadratic equations using the completing the square method. And so we're going to go right to example number 4. We have x squared plus 4x plus 10 equals 0. So again, your first step, check that a. That leading coefficient has to be 1. Okay? And it is. So good. We checked it. So a equals 1. Check. Okay. The second step, move the constant. So we're going to subtract 10 from both sides. So now we have x squared plus 4x plus, we're going to add something there. So leave space to add the constant when we complete the square. Here we have negative 10 that we just moved over. And then plus, okay, whatever we add to one side, we're going to add to the other side. So that's why we have the two spaces. Okay, step number 3. This is where we complete the square. So we're going to look at b on the left-hand side, which is 4. b equals 4. We're going to take half of that. So half of b is 2. We're going to square that. So 2 squared is 4, and that's what gets added here. Different color. Here and here. Okay. All right. Next step is to factor. So the left-hand side, we completed the square so that we could factor this as a binomial squared. It's x plus 2 squared. And then on the right-hand side, we're going to add a negative 10 and a positive 4 and get a negative 6. Next step is square root property. So we're going to take the square root of both sides. And we're going to remember that plus or minus on the right-hand side, right? So square root property, so square root plus or minus square root of negative 6. So here we have x plus 2. And here we have a negative radicand. We have a negative under the square root sign. So if you remember that, that means complex number, imaginary numbers, you're absolutely right. So let's factor out that I, right? So this is negative 1 times 6. And we're going to take square root, and the square root of negative 1 is I. So this becomes plus or minus I times the square root of 6. Okay, so that means we have two equations to solve. We have x plus 2 equals positive I square root of 6, or x plus 2 equals negative I square root of 6. Add the 2 over, or subtract 2 to solve for x. So x equals negative 2 plus I root 6, or x equals negative 2 minus I root 6. And that means that our roots are two complex conjugate roots. Do you remember what that meant? They're conjugates because that middle sign is these two signs are opposites in the middle. So we have a plus bi here. I put the I in front though, right? And we have a minus bi here. These are complex conjugates. Okay. All right, let's go to number 5. Again, a is 1. Move the constant. Leave the x squared minus 5x plus, leave room for completing the square. Negative 3 plus, leave room for completing the square. Okay, so now we're going to complete the square. And b is negative 5. And we need half of that. So this is not an even number. So I'm going to make it into a fraction, put a 1 under it. And this means that half of b is negative 5 over 2. And now you need to square that. So square this negative 5 over 2. And we get 25/4. yes, this ugly fraction gets added here and here. So 25/4. Okay. So to factor the perfect square trinomial on the left, if you recall from our previous work on completing the square, we're gonna, this guy that you squared, that's what goes here. -5/2. Okay. Equals, over here, I have a -3/1 plus 25/4, and I'm going to get a common denominator of 4. So here's -12/4 plus 25/4 to combine those two fractions here. And so that means like I have a 13/4. So that's what comes over here, 13/4. Okay, I know this is looking bad, but we got it. We got this. Okay, what's the next step? If you said square root property, you're right. And then we're going to remember that plus or minus, right? On the right-hand side. So square root plus or minus square root. So here we get x minus 5/2. Now, over here we have, I'm going to go ahead and split up that square root of a fraction. I'm going to take square root of 13 over square root of 4. Do you see why I did that? Because square root of 4 is a perfect square. So we have, let's rewrite, x minus 5/2 equals plus or minus square root of 13 over 2. And now we have two equations to solve. So the first equation will be x minus 5/2 equals a positive square root of 13 over 2, or x minus 5/2 equals a negative square root of 13 over 2. Add these over, these 5/2. So x equals 5 plus square root of 13. And we can put it all over 2 because they have a common denominator. These are not like terms, so we're going to leave them like that. Or x equals 5 minus square root of 13 all over 2. And what kind of roots are these? Since you have those square root of 13s, if you said irrational, you're right. Irrational roots. Okay, I know that one. That one had a lot of interesting pieces to it with all these fractions, so you may want to rewind this and watch it again. Okay? All right, let's go to number 6. Okay, this one is 3x squared minus 6x plus 30 equals 0, and I gave you a big hint here. What's A? A is 3. A is not 1. Uh-oh, this is our first one where A is not 1. So it says divide both sides by A first before completing the square. So we're going to divide everything by this 3. Divide by 3. Divide everything by 3. So let me rewrite. Because I'm going to go ahead and I'm going to divide by 3, divide by 3, divide by 3, divide by 3. Everything gets divided by 3. And then reduce. And so now we have x squared minus 2x plus 10 equals 0. So not so bad now. Now it doesn't look so bad. These are like the ones we've been doing. So we are going to subtract the constant, move the 10 over. X squared minus 2x plus, leave some room, equals negative 10 plus, leave some room. And then b is negative 2. Half of negative 2 is negative 1. Negative 1 squared is 1. So this is a 1. And whatever we add here, we add here. Factor x minus 1 squared. Over here, add these together. We get a negative 10 plus 1 is a negative 9. Square root property. Running out of room here. Plus or minus square root of negative 9. Uh-oh, complex numbers. Let's see, let's put this over here. Okay. So again, square root property with a plus or minus on the right. This is x minus 1 equals plus or minus, okay. We have to take out an I, don't we? Square root of negative 1 times square root of 9. This is I. This is 3i, plus or minus 3i. And now we get x equals 1 plus 3i, or x equals 1 minus 3i. What kind of roots did we get? We got two complex conjugates. Yep. Did you follow all that? Okay, we get to do it one more time. Look at number 7 because our a is not 1. So we're going to have to divide everything by 2. So let's rewrite. Just rewriting the problem here. And the first step is divide by a, which happens to be 2. So everything gets a 2. Just like that. Okay. So this is x squared. This is 15 halves. Ah, we have a fraction. Darn. And now let's go ahead and subtract the 25. So I'm going to leave some room here for my completing the square. And then this is going to be a negative 25 halves. And yes, we have ugly fractions, but we can do this. So b is negative 15 halves. Half of b is 1/2 times negative 15 over 2, which is negative 15 fourths. Okay, we got to square that. Negative 15 fourths squared is equals 225 over 16. So that's what's going to get added here and here. Yep, I know it's looking bad. Okay, but we can do this. Okay, let's factor this left-hand side. Remember, this is always going to be x, and then whatever you squared to get that 225 over 16, which was negative 15 fourths. So that's what goes in the parentheses, negative 15 over 4 squared here equals, now we got to add these two up here, negative 25 halves. So I need 16s down here, right? And 25 times 8 is negative 200, plus 225 is 25 over 16. Okay, now we're going to do our square root property. Square root plus or minus over here, square root of this guy. So we get x minus 15 fourths equals, gonna split up this radical, plus or minus square root of 25 over square root of 16. So we got perfect squares. So they were kind to us at least, right? This is what? Plus or minus 5 fourths. So my two answers, x minus 15 fourths equals positive 5 fourths. So I'm going to add 15 fourths to the 5 fourths, and that's going to give me, looks like 20 over 4, which is 5. Ah, not too bad. So x equals 5 here. X equals 5. And then over here I get x minus 15 fourths equals negative 5 fourths. Add 15/4 to the -5. So plus 15/4 plus 15/4. Now I get x equals 10/4, which reduces to 5/2. So my two answers are 5 and a 5/2. Rational. Nice rational roots, which I would personally use my calculator to check. So I recommend you do that. Okay.